banking, finance. Again, let's give another minute or so for everybody to kind of join, and we'll get started. Let's maybe start this up now. First of all, thank you everyone for joining today's webinar. Again, we're going to discuss big data for finance. And kind of an agenda for today, just a few intros, a little big data overview, and then, the purpose of this is to dive into use cases that are very specific, for finance, banking, insurance type, verticals. How you kind of get there, kind of a recap, and then Q&A. At any time, if anybody has a question or something specific you want me to go over, even though I have a bunch of slides, I'm very dynamic with this, so if you have a question, I believe there's an option down below that says questions. Feel free to kind of just raise your hand, ask any question you want, and I'll do my best to answer it. Again, I like to make it as interactive as possible, and so everyone gets the most out of it. And just so you know who I am, I'm Mark Martina. I'm a system architect and managing partner with TechD. TechD, we're premier IBM business partners, and we pretty much implement anything that has to do with data. So ETL work, data warehousing, big data solutions, Hadoop, and then any reporting tools that go on top of it, things like Cognos or SPSS for predictive analytics. So we're usually the people in the field actually implementing these solutions. So even though some of the topics we're going to cover may be a little bit finance generic, I'll throw in some things for specific things we've done, and if anybody has any questions, I'll give you some kind of real life answer, hopefully. All right. That being said, let's kind of get into it a little bit. So big data. I like to start off with this slide. Big data does not necessarily mean Hadoop. So when you talk about big data, it's a lot of buzzwords, and people aren't necessarily even sure what exactly big data is, but they know the word, they know Hadoop, and they equate the two together all the time. I'll go into Hadoop a little bit during this presentation, but one is not exclusively mean the other. Hadoop is a subset of big data, and it's also an optional subset of big data. You can have a complete big data implementation that has nothing to do with Hadoop. Most of them do, but it's not a requirement. So do not get one, confused with the other, because they really are not that interrelated. All right. That being said, let's continue. So what actually is big data? All right, so let's start a little high level and kind of work our way down. All right, it's kind of like your V's. So if you have a lot of volume, variety, or velocity of data, that kind of puts you into the big data category. All right, so what exactly does that mean? Volume. I have a lot of data, just normal everyday data, but just large amounts of it. 12 terabytes of data. I have every banking transaction for every customer for the last 10 years. That is a lot of data. I have every stock bought and sold for the last decade. That is a lot of data. Right? Volume becomes the challenge, right? Because there's a lot of insight in there, and looking at summary reports of Q1 versus Q2 does not get the needed information out of there. So to do that, a lot of volume, and that puts you kind of in the big data category. So that alone, just a lot of volume of data, makes you big data. Next is variety. All right, we've got crazy amounts of data nowadays. Right, so examples: surveillance camera data. You can actually do things like images, videos, documents, free-form text. Right. I heard recently, so we talk about surveillance data. I mean, what can we analyze with surveillance data? I heard actually recently that IBM was directly involved with determining the actual bombers of the Boston Marathon a few years ago. What happened was there was a lot of data, and the police were trying really hard, but the manpower, no matter how many people they had, it was just too much to go through. They pretty much gave all the videos to IBM. They told IBM hoodie and backpack. I think they maybe had a color for the backpack, and that's all they had. The next day, they tracked everybody down because IBM just put it right to their system. They probably had Watson behind the scenes. They just scanned everything, and voila. They determined what video had what information that they needed. and they were out the door. Done. That's variety, and that's what we're talking about, usable insights. Next, velocity. All right, so what's velocity? Velocity essentially means real time. All right, things that are moving fast are a challenge. It could be a small amount of data, but if it's moving quick and I need to analyze it on the fly, that's a challenge. Right? And the combination of all three of these is your veracity. So that would make up your 4 V's of big data. If I have a lot of data, if I have crazy variety of data, surveillance feeds, tweets, all that social media, people typing in this thought, that thought, comments about things, variety, and then velocity, real time. Right? If you have any of these, and pretty much everybody on this call has all of these, this puts you into the big data category. So that's why we're here. All right. So why are we doing this? Why do we care about getting this insight out of here? Well, it's a different world nowadays, right? So competition is a lot stronger than it used to be. There's a lot more regulations. There's a lot more pressure for margins. It's not pretty much the 80s now. We've got a new world with a ton of data, which has a lot of insight, and we have a lot of requirements and a lot of competition out there, and we need to utilize this to either get us ahead of the competition or some cases, keep up with the competition, right? And in all cases, to make us more optimized than we currently are. Okay. Now, banks, people in the finance field are acting on their top business imperatives, create a customer-focused enterprise, drive innovation while managing costs, increase flexibility and streamline operations, optimize enterprise risk management. These are all things that make you, a smarter company. Let's get into this a little bit more on the specifics, right? So here's some stats that, are kind of showing you how data is going, right? 50%, 40% of people socialize more online than they do face-to-face, right? It sounds a little crazy, but, if you take a look at anybody in the millennial, you'll see right away that's kind of how it works nowadays, right? So your online presence and what you do with online information is actually very important nowadays, right? 1 out of every 7 minutes are spent on Facebook out of people that are online. So obviously, this data is important. We need this data. Global customers are all using mobile devices now. So mobile device data is big. So all these different data sources didn't exist or barely existed, 10 plus years ago. All right, so data explosion, all right? Here we're in 2016, we're in 2020, everything's going, through the roof. Your normal data, social media data, sensor data, things that are bringing in real-time data, it's all growing, and there's insight to be had in it, but it's causing a lot of technical problems. Your data warehouse or your data repository or whatever you have currently is now have to be 10, 20, 30, 50 times the size, and have to have all this different type of data and all these different velocities. It's going to cause a problem to your current infrastructure. All right? So we have to go through some use cases on why we need this data, and then we'll kind of go over also, what do we need to implement to actually get the solution off the ground. All right, big data is transforming different industries like the banking industry, from incomes to outcomes, limited tunnel vision, unlimited future focus. So again, we're getting more insight. We're not looking at what's now, we're looking kind of towards the future, more predictive analytics. Again, we'll get into some more detail with that. All right, so data is emerging as the world's newest resource. Outperformers are 3.6 times more likely to be applying analytics than their peers. Right? So these are the reasons why we need to start looking into big data. These are obviously a little bit more on the generic side, but we'll move it down. Now, here's kind of where we were versus where we're going when it comes to shifts in paradigms. Right? The traditional approach, banks, finance people, they're analyzing small subsets of data. Right? They're cleansing data before they actually do any analysis on it. They're starting with some type of hypothesis that later on they're going to try and prove using the data, right? And then they're analyzing data, after it's been cleaned, loaded in a warehouse, and that's kind of the past. That might be where you are now. That's where everybody was, 10 plus years ago. But now everything's kind of a little bit more forward-looking, right? When it comes to analysis, if somebody wants me to do predictive analysis and they ask me what kind of data I want, my first response is, I want it all. I want it all, right? All might not be available. So sometimes I have to qualify somebody. All right, well, do you have this data? Great. Are you storing it? No. Problem. We need to store it. I need these columns. I need these attributes to increase the probability of my models being accurate. I need this data to do better modeling, to do better predictive analytics, right? That's a big change now. Instead of looking at little segments of data, we're consuming all of it at the same time. And that's a lot of challenges. We need to store the data, and then we need the data to be quick enough that we can analyze it in volume, right? And it's a little different now. We don't come up with a hypothesis. The data kind of comes up with the theories for us, right? So you explore all data, then you identify the correlations. So we explore it, correlations, then we get our insight. So we're looking at it from a different perspective. Before we said, well, we think this is true, let's prove it out. Now we're well, I've got all this data. What can I figure out because of this? And now it comes up with the theories for you. So we're actually looking at it in a different direction, and it's a better one because it'll pop up things you've never even thought of before. Right. Analyzing information and then cleaning it as needed. You know, some information is just naturally kind of dirty, especially things like, you know, tweets and so forth, right? You're going to analyze, you're going to work with it, and then you're going to find outliners, and based upon that, you know, maybe you'll actually run a cleaning process. And then analyzing data in motion, real-time analytics, right? Somebody calls up the bank, you should know who they are, you should know everything about them. If they're looking for an insurance policy, you should automatically know who they are, what they're doing, what their score is, what's the probability of them being fraudulent. All this information is real-time analytics, but you can't do it. You can't put the tools in place if you don't have that big data infrastructure set up to actually do all these use cases. Right? So the whole purpose of big data is to allow all these approaches to be possible. Okay? Your old school, you know, warehouse data repositories, they're not going to work with this. Right? So we need to have those V's: volume, variety, velocity. It doesn't sound like a lot, but it is. From an infrastructure point of view, it's massive changes. Right. More shifts. Traditional approach. You know, what has happened and why? Well, where's sales last year versus the year before? Right. Traditional approach again. Right. Intuitive analytics for everyone. Right. Analytics as and when you need it. Cognitive computing. Right. So this is kind of your traditional approaches. Now, this is what it looks like with big data. Right. Predictive analytics. So we're not just looking at what happened, we're looking at what's going to happen, right? Intuitive analytics for everyone, embedded in everything. Analytics are everywhere, integrated in every different department. Not just this one person who gets the analytics. Now, everybody gets it because it helps out everyone, right? Real-time analytics again. Right? And then more cognitive computing, being predictive. So looks kind of like an Atari graph, but this is probably what everybody's warehouse looks like or did look like. Hopefully you're at least at this stage. If you're not, you know, please reach out. This is kind of what your traditional warehouse looks like. You've got all these different applications with data in it. You maybe put it into a staging area with your ETL tool. From there, you put in your warehouse. You segment things out, these itty-bitty little data marks, and then you put all your analytics on top of it, right? Old school. I mean, there's nothing wrong with these components, but there's just so much more it's missing, right? So now we go back to, you know, new school, big data and analytics, right? So it's no longer just some ETL tool that dumps data into a warehouse. There's a lot more involved. There's governance involved. There's real-time processing that's involved. And it's not just like a warehouse. It's an enterprise data warehouse with high capacity, high processing ability, the ability to actually do analysis not on, you know, weeks over weeks, quarters over quarters, but multiple years analyzing all the data simultaneously to determine predictive outcome. Major changes. There's nothing wrong with the old one, but any of these use cases, any of the things I'm talking about specifically for these finance use cases, they're just not going to work with that environment anymore. It's outdated, it's too slow, and it can't handle the data anymore. All right. So patterns that are emerging. What are important things that people are looking to get out of big data? All right. Right in the middle, fraud detection is huge. Fraud costs everybody in finance a lot of money. Fraudulent claims, fraudulent people creating bank accounts, credit cards. It's a big problem. We want to detect fraud. We want to cut it off. We want to give people a fraud score before they even apply. All right. Top left, we've got cross-selling, optimization. Right. Every customer of yours should be treated individually, not as one generic customer. You need to really treat them differently to optimize your actual offerings. Credit risk management, consumer payments. These are all these different areas that are big now and require actual big data solutions. All right, so we're going to focus on a few areas that are specific to finance. All right, optimizing offers and cross-selling for your existing customers. Fraud detection. You save 1 or 2 percentage points in fraud, the dollar amount, the ROI is off the chart. Security. Big data means big security risk. You need to lock it down. You have every bit of information in there. You do not want to be on the 6 o'clock news as somebody who got broken into. All right, so where do we go? All right, big data objectives. Most people are kind of working on customer interactions. Followed by next would be risk management and fraud. So it's kind of your big three. Right. There's a chart of kind of what everybody's looking for to get out of big data. Employee collaboration seems to be kind of dead last, I guess because it's more of an ROI type thing. I think the other ones give you more bang for the buck. So they're pretty much right. So this is kind of where everybody's kind of pushing big data in the industry, the reason for it. All right. So optimize offers and cross-sell. All right. How can I improve our understanding of customer needs? How can I target the best cross-sell offer at the right time? How can I better identify offers customers would most likely accept? That's a big one, right? And just so you know, the slide deck will be sent out to everyone afterwards, so you don't have to worry about writing anything down. You'll have all of that. But these are big questions everybody has. And so what are our options? What are we trying to do? All right. We're trying to get actual, concrete outcomes. So head of customer loyalty, unable to stem attrition due to poorly timed and targeted retention offers. You should be able to tell if the person has a high probability of churning, if they want to drop your insurance policy for another, if they want to go from your credit card company to another. There are a lot of telltale signs inside the data. But one, you've got to store it, and then once it's stored, you've got to analyze it, right? Big data. Low campaign response rates in marketing. Customer analytics, unable to quickly analyze all the data for better predictive analytics. Predictive analytics is without a doubt one of the biggest challenges when it comes to resources on your data. Predictive analytics does not do analysis of a year or a quarter over quarter, month over month. Predictive analytics requires you analyze patterns of large volumes of detailed data going back multiple years, 3, 5, 7, 10 years, to find patterns, to determine segmentation, and to group everybody appropriately, right? It is a big challenge. If your system is not set up to do it, it will take you forever. One of our clients was using a predictive analytics tool. The query took 4 hours. We swapped out that old-fashioned warehouse with the Atari graphics for a big data implementation, and it went from 4 hours to, I believe, 46 seconds. Game changer. You go from batch processing to real-time analytics, ad hoc, on-the-fly analysis. 4 hours to 46 seconds Same data, same volume of data, same SQL query. 4 hours, 46 seconds. That's the difference. So we're not talking we're going to tweak something a few points here, a few percentages there. A big data solution should take your response time to the next level. We're not talking 1 or 2 times faster. We're talking 100, 200 times faster. In this case, it was even more than that. It was more like 400 times faster. Right? That's what you're trying to get out of it. That's the volume, and that's the velocity. We need fast over large amounts of volume. 4 hours, 46 seconds. All right. So here's kind of just a real-life scenario, right? So someone, Aki, she goes to the bank. They ask her if she wants a credit card, or they send her some junk mail, generic, all right? Everybody gets it, and it's kind of a blow-off, right? So we're just kind of generically sending things out. And this is what we end up sending, preferred gold credit card. That's what we send her, right? But if we actually take a look at all the data we currently have, because she's an existing customer, she has credit cards with us. She has bank accounts with us. She has insurance with us. We already know a lot about this person. We know what part of the country they live in. We know their age, the demographic that they're in. We should not treat this person like everyone else. We have too much information to do that. That's where our big data analysis comes into play, right? She has a mortgage. She's called the call center about loan processing times. We know what her credit score is. She looked at mortgage rates on our website. Yeah. So what we do is we need to analyze all of this data and come up with better conclusions. So we take all this data into account. Instead of sending out a gold card offer, which I probably get 30 of a day, we decide it's better to send her a special mortgage rate offer. And now the probability of success goes way up. Big deal. Again, your website is also a very valuable tool. If you have certain products like, example, like Tea Leaf, which I believe is acquired by IBM recently, it literally tells you every click a person does onto a website. And that data is very useful. It's useful in a lot of ways. One, it's useful to see what they're looking at. Two, it also helps you for fraud, in case somebody's actually trying to, do some type of security shenanigan, right? So a lot of people I know out there have Tea Leaf. That data is extremely valuable, or if you have any product like it, you need to keep it, store it in your big data solution, and use it going forward. All right. So here's an exact example of how we use our big data analytics to determine the appropriate customer response, to actually give them something they want. And you typically have the data. The question is, are you storing it? And what are you storing it in? Is it something that's easily accessible to? And is it fast enough? Speed is required in big data solutions. Right? I need to do real-time analysis. All right. All right. So real-time business value is driven by these cross-sell offers, right? Increase revenue and profits. That's obviously a huge goal. Improve customer retention, huge goal. Deepen customer satisfaction and affinity. If they like us, they will stay with us, right? Here's our KPIs. If we want to keep customer retention high, we need to identify if somebody's at risk. We need to contact them. We need to have a save offer. That save offer should not be generic. It should be customized to that person. And if we can stop that by 10 or 15%, our ROI is right there. Huge. That's one use case. All right. So behind the scenes, what's kind of going on here? All right. So multidimensional customer insight drives successful real-time customer interaction. So data, real-time or historical. How? Right. Email and chat transcripts, call center notes, web click streams, in-person dialogues. All that information. Why? We want to know their opinion, their preference, their needs, their desires. Right? Who? Attributes, characteristics. We need all that descriptive data as well, behavioral data, orders, transaction. This is all the data that you most likely have. Keep it, store it, put it in your big data solution. Now with it, what can we do? We can do predictive customer insight. I know when they churn. I know what they might actually go after from an actual marketing perspective, right? So you most likely have this data. Are you keeping it? Are you storing it? And what are you storing it in? So that's big data for you. All right, so now how does it look like when we actually put some products in to the actual big data map I showed you earlier? All right. Well, from IBM perspective, there's something called streams. Streams is kind of like an ETL tool. The only difference is it's in memory. It's real time. The data never lands. It's always in memory. As a result, it's designed for scoring things on the fly. If somebody calls up and they're asking about a credit increase, if they're asking about a new insurance policy, you should be scoring them on the fly. You should take that data, score them based upon who they are and others in the similar category to themselves. Based upon that, you should have a fraud score. What's the probability this is fraudulent? If it's not fraudulent, what should the credit score be? What should we increase their line of credit to be? If they're calling up just for something generic, what should I offer them? What has the highest probability that they'll say yes to? Everything should be specific. Those screens that pop up for the customers should have detailed data and offers specifically for them. Right? There's streams. InfoSphere Big Insights, that's Hadoop. That's IBM's flavor of Hadoop, is Big Insights. Hadoop is generic, it's open source, and nobody uses just plain Hadoop. So everybody buys a flavor of Hadoop. Big Insights is IBM's flavor of Hadoop. And it's designed to store large volumes of data and also unstructured data. So anytime there's a comment, a tweet, a survey, where people are typing things in, that data is going to go into Hadoop. Pure data for analytics, also known as Netezza, that is your warehouse appliance. It takes your old school data warehouse, which returns queries in 4 hours, and it brings it back in 46 seconds. That's what it does. Transactional data, structured data, it takes everything, it makes your job easier and runs everything faster. And then, of course, master data management is pretty self-explanatory, right? Make sure our data is managed, make sure we have security around it, make sure there's governance. And then that's our big data environment. Now, on top of that goes all your tools. You've got Watson in the cloud if you want it. You've got predictive analytics with SPSS. You've got content analytics with Cognitive Analytics now, right? So you've got reports, dashboards, predictive data, right? But none of that can live, none of that can be successful without the infrastructure. Right? So that's what we're talking about. All right, next, another important topic, fraud detection. All right, mitigation. We do not like fraud. We want to decrease it, right? Again, it's becoming more and more of a problem. It's becoming more tricky to detect. Fraud schemes are increasingly complex. 12 per second. Right? 80% originate in organized activity. So it's not just this one person who's kind of coming over and trying to do something fraudulent. It's essentially an organized group who is actually trying to commit fraud. You see them all the time with your phishing emails where they try and pull out your account number and this and that and everything else, right? We need to be prepared for that. All right. Cost of fraud have gone up, not just on the money that's lost, but also if data's lost, what it does to your reputation as a company. It's important. Your customers need to actually trust. Right? Confidence and trust is a choice nowadays. Right? There might be you and a competitor. If they trust one over the other, that might be the differentiator. 71% customers will switch banks due to fraud. That's a huge statistic, right? 46% of customers leaving avoid companies with a security breach. If you're in the news of having a security breach, you're not going to be that desirable. You will actually see a loss, right? How can I analyze large amounts of data for fraud? How can I detect fraud before it impacts my customers? Right? Here's two big questions. Let's go through it a little bit. Again, if anybody has a question, please feel free to kind of, ask it, and I'll do my best to answer it. All right, head of fraud management, obviously an important position. All right, high level of fraud-related losses, that's a challenge. We want to decrease that. The benefit, obviously, reduced fraud. All right, pretty simple, pretty straightforward. CIO, difficulty in analyzing volumes of data. If we can speed it up, we can improve speed and accuracy of our fraud detection. Right? There's a big difference between batch and real time. Right? If our fraud detection is batch, that means it's happened and we're catching it after the fact. If it's real time, we're catching it as it's happening, or maybe even before it kicks in. That's speed, that's velocity, right? All right, so big data analytics approach is to counter this fraud, right? All right. Social network analysis, identify relationships across entities. Sounds a little weird, but everybody's kind of related. If somebody has a high fraud score and they're related to someone else, that should affect that other person, right? Predictive models. Predictive models they're excellent for detecting fraud, but they require a large amount of data and performance. Again, a data solution. Business rules specific to your exact business. Based upon our past, we've realized this is important, we can't do this. Having those rules in play. Case management and then fraud insights as well. So managing fraud, metrics. So here's Bill, right? Let's go through another scenario. All right, he fights fraud, $100 million annually in fraud. It's a complex problem, we all know that. All right, and they're constantly looking at new ways to actually, determine fraud, right? It's never-ending arms race is what's described as here, but it's a constant challenge which is always changing, right? That's why your predictive models are always changing. That's why you need to run them more and more, all right? So Bill's got a ton of information, right? Identity patterns with each transaction, investigations that he has details about, call accounts, all this different data that's actually coming, through to him. He's got fraud trends that he has to see and deal with. He's got a fraud score model he needs to develop and constantly adjust over time. So he's got different data, he has different things he needs to do, and it's a challenge for him to do it, all right? All right, so if any chance to keep up with all these different things, you've got to kind of, organize a little bit better, all right? And your big data solution is going to help you do that, right? So predict, screen, prioritize, investigate, monitor. You've got to have a pattern. You have to have flow. It's kind of part of your, your flow, your master data management. All right. And then from this, we're going to be able to predict, improve scoring model. We're going to have faster screening, prioritize, improve prioritization based upon this. All right, so we're going to take our different data and everything on every end is going to be improved. And everything is interrelated, right? Analytics is going to go to data management. Case management is going to circle around to data management as well. Your analysts have instant access to your information. Use information from a variety of different sources to determine patterns you couldn't tell before. And your data is consolidated across different channels. We don't want siloed data. We need to have it all together for optimized analysis. Right? Obviously, our objectives, reduce cost of fraud losses is huge. Reduce cost of the actual screening and monitoring themselves. Reduce cost of the actual investigations, things we have to do. So now, again, we go back to our big data platforms. Your big data platform should work with all the use cases, but certain components will be more important than others depending on what you're doing. Right? So again, we've got a pure data for analytics. We've got a big insights for unstructured data. We've got our streams again. Right? But now, when it comes on the reporting side, we've kind of made a little bit of a change. So it's kind of the same infrastructure, but now we've got fraud management tools. Right? So instead of just doing reports and dashboards and things like that, we now have fraud management tools and predictive analytics tools that we're putting on top. But again, it's going on top of the same thing, the actual same big data source. All right. And obviously, the next one is security. All right. So financial services are at the highest, kind of one of the highest risks for attacks. Right. So it's manufacturing first. Right below that is finance, insurance, real estate, and so forth. All right, so security teams may shift from a conventional defense to kind of a think like an attacker type mind frame, right? So we're going to go from the left to the right. Audit, patch, block, everybody kind of does that, but you need to detect, analyze, and remediate, right? So you need to be kind of ahead of the curve. You need to be more proactive, right? The things you're doing here are very generic, very broad, right? Patch everything, broad. Do some auditing, do some generic blocking, fine. On the other side, we're looking at the data and determining more insight to actually be more specific on what we're stopping, what we're going after. Right. We're going to create baselines of system behavior. We're going to collect everything. We're going to automate these tasks. Right. How can I analyze large amounts of data for cyber threats? How can I protect against cyber threats and ensure regulatory compliance? How can I detect against threats as they are happening? Right? The reason why I brought up T-Leaf before was one of our clients actually took the T-Leaf data, they dumped it into big data, which I believe is actually an Netezza appliance, did an analysis on it, and they were able to detect based upon patterns that their actual website was under cyber attack and they didn't know it. They determined a set pattern of people who were actually going and crawling through their website looking for weaknesses. How do we do that? Well, we need to store that data. We need to store it in a place where we can get to it quickly. The whole purpose of big data. Right? All these use cases work with your big data solution. Right? So, problems. Difficult to detect attacks. Right. What's our benefit if we can? Protect bank reputation, reduce financial exposure. Reputation is big. Difficulty analyzing high volumes of data. Again, that's a huge problem. All right. So again, different use case, but same problem. Analyzing large volumes of data is a problem. Right? So that's why you need to essentially boost up your existing infrastructure. Step one, collect and store massive amounts of security data. Right. I need the data to actually be able to analyze it, right? So the top section, we've got kind of our traditional. Alerts from security sensors, security logs from servers, vulnerability and patch information. It's kind of where everybody starts, right? But once we start bringing in big data, we have all these other options, all right? Email and social activity. That's a lot of information. It's a lot of unstructured information. We can store that in our big data solution. Right. System audit logs, we can store that. External threat feeds, we can pull in. Network flows and anomalies, we'll store. Right. Malware samples and behavior, full packets and DNS captures, full packets of network data we can store and analyze. Right. All these data sets we can store, analyze, assuming we have our big data infrastructure in place. Now we have the data, right? So you need the actual infrastructure first. Once we have the infrastructure, once we start collecting the data, then step two, we can actually start analyzing it. All right. Apply real-time and historical analytics to build insight. So what does that mean? Well, Historical analytics helps you with, well, what happened, right? Well, I know there was fraud before. Well, let's scan our history to determine the patterns and now utilize those going forward. Right? How did it happen? How did we find out about it? What were the signs that it was going to happen? Right? And using that, we're going to be able to create models that'll actually show us what's going to happen before it does. But again, we need the data, and we want all of it. Again, when ME asks you what data you want, when it comes to big data, when it comes to predictive analytics, you want it all. I want it all. All right. Data sources. What are our options? Security devices, network activity, right? User activity and behavior, web logs, business transactions, all this unstructured data that I'm able to acquire. Those are my data sources, and there's a lot of it. It's high volume, some of it's real time, so high velocity and unstructured. So that's our variables. We have all three of the B's that make it big data, right? So what are we doing? Well, we're storing it. Storage of hot, warm, and cold data. So what does that mean? Well, hot data, warm, cold. Cold data is more of your historical data. Warm data is kind of medium. Hot data is things that are happening right now. Right? Structured, unstructured, distributed infrastructure. We preserve the raw data. The raw data is important. When somebody looks at a report now, they don't look at raw data, they look at summarized data. But when we do analysis, we need the raw data. There's insight in there, store it. You might not store it in something in the Netezza appliance. You might do some offloading into your big insights, your Hadoop implementation, but we need to store it. Everything is valuable. Do not get rid of your data. Then once we have it, we analyze it. So it's stored in our big data implementation. Now we're doing our analytics on it. We have our different user interfaces. We had ad hoc queries. We have predictive analytics, decision modeling. Okay. So it's a two-step process. First, we need the infrastructure with the data in it. Then we can do all the analytics on top. That's how it works. And so, where you are now, you've got to see, kind of analyze where you are currently. And then from there, how do I get here? What are my steps? And we can obviously help you with that. And obviously, why are you doing it? What's the reason? The business objectives, right? Reduce cost always, right? And then reduce loss of security breaches. And again, if we look at, our infrastructure again, some of the similar, tools are there from an infrastructure point of view, and then a lot of times the front end changes a little bit. Business intelligence for analytic reporting, predictive analytics to kind of catch things off before they even happen. Security intelligence, right? But all those things sit on top of your big data implementation. All right, so what are some of the advantages IBM has when it comes to analytics and big data? Well, one, they have pretty much everything. All right. IBM has pretty much every product you could possibly have in your big data implementation. They have something for parallel processing, low latency, scalability, data optimization. All the tools are there. They have the Hadoop. They have the appliance warehouse. Speed, confidence, tons of success stories, tons of use cases that have been successfully implemented. As a partner, we've implemented a ton of them. IBM worldwide has implemented, obviously, many more. All right, so why IBM the partner for success? So what is it IBM and their products actually help you when it comes to actual big data, right? Imagine it, realize it, trust it, right? So they're unmatched industry and domain experience, right? They're experts with everything. They've got a lot of real-time analytics use cases. We have them as well, and we can share those with you. And then trust, right? So you trust the data. It's one source of data that can be trusted. All right, so we're giving you all the reasons to actually go with big data implementation. All right, so what do you do now? What are your next steps? All right, and these are kind of like very generic, but they kind of get you there. So think big. All right, so where are you at now? Where do you kind of want to be? Let's kind of think about it. What's our goal? Out of our use cases, which one are going to give us the biggest bang for the buck? What do we have? Let's go over all of our different options. Well, we've got this use case, this one, and all the ones we mentioned probably apply to you. All right. Pick your spot. All right, we've got these use cases. We think these two are the best. Out of these two, we think this one we have the data for, and this will be the easiest for us to implement. Great, we found our use case. Now what do? Now we actually execute it. Now we go with that use case for this insight. All right, so what you're going to do is you're going to expand from enterprise data to big data, right? So you're not throwing away your old environment, per se. You're kind of giving it a facelift, we'll say, right? So we're not getting rid of a data warehouse. We're not getting rid of your traditional sources. All that still stays in play. What we're doing is we're adding things. We're adding unstructured data. We're adding new data sources. We're adding real-time processes. And sometimes we're taking your data warehouse and we're giving it kind of a little bit of a turbocharge to get that performance out of it you want. Right? So it's not like you're throwing away your current world. You're augmenting, enhancing it, so let's prepare for everything going forward. So you're going to have to put together your future state architecture. So your architecture might look like that original kind of picture with the old school graphics. This is kind of where we need to get it going to. Our data, our warehouses, our big data analytics, our different streams, our cubes, everything that we need, all of our different integrations, kind of get us to where we need to go. So we need to kind of map all of that out. That's your future state architecture. This is kind of a high-level example. And ideally, this is kind of your end goal. The complete data management environment where you have everything in your big data solution, but again, it's an iterative process. You're not going to start with something small and then turn into this a few months down the road. It's going to be a phased approach. Where am I at? Where do I need to go? Where do I want to start? You've got to kind of pick out your battles. Maybe I don't want to start with unstructured data now. Maybe I just need to improve the performance of my warehouse, add more data to my warehouse so I can do some predictive analytics on it. Or maybe a lot of your insight is in unstructured data. So now you want to bring in that Hadoop big insight, component to your actual warehouse. So you have to kind of pick your steps based upon your use case and the data you have available to you. And again, here's kind of the architecture and the products that would go on top of it. So we got data stage and streams, bringing data in, either batch or real time. Big insights as either a landing zone or that repository for the unstructured data. True data for systems, true data systems for analytics, also known as Netezza, for that high-speed, powered warehouse. And then on the right, all the different analytics tools that are going to run on top. So how does the process go? Unfortunately, it goes kind of around and around a little bit, right? You're identifying your use cases. You're going to do some analysis, design your little prototypes, architect things out, demo your findings, kind of streamline things a little bit, do some more analysis, go through it again, make some more architecture changes, and kind of go around and around and around, analyze, perform, recommend, explore. And it's kind of a never-ending circle because things constantly change, data sources change, more data sources are added. So it's kind of the flow and how it's going to work. All right. And obviously, if you have any specific questions, call us, email us, text us, whatever you want. I have no problems getting on a call, ask you about your current infrastructure, where you're at, and where you want to go. If you're having performance problems or you're lacking certain data or you need to kind of get a little boost or a little idea of what direction you should go, I tried to make these use cases a little bit more specific to, finance, but in the end, it really depends on, what your environment looks like currently and the specific use cases you want to work on. That's going to really say, this is where you need big data to go for your next couple phases. This is the roadmap you need specifically from a technology point of view. You know, if you have any questions, we'll do, you know, a free big data deep dive. That's not a problem at all. We'll tell you what other people are doing, the pros, the cons, and where we think you should be and how we think you should get there, and kind of get you on that right track. And it's complicated. Like, nobody knows all the answers right away. All right. And of course, also, if you need a little bit more information, you go to IBM.com and just do /big data, and that'll bring up a lot of information as well. But again, feel free to reach out to us. And I believe that is it for the slide decks. If anybody has any questions, please let me know. Yep, that's the one. All right, so a lot of the products I'm talking about, almost all of them with the exception of Netezza, is available on-prem, or you can actually do a cloud version as well. So cloud seems to be very popular nowadays. So you can have, you know, DashDB as a warehouse alternative to Netezza in the cloud. Big Insights for Hadoop is in the cloud. DataStage for an ETL tool is available in the cloud. Everything I've talked about is pretty much available as an on-prem or cloud solution, or if you want a hybrid solution where you've got part in one environment and part in the other. Any other questions? None? Okay, great. I really appreciate everybody's time. Hopefully it was informative. If anybody has any other questions, again, please feel free to reach out. You can just send me an email or reach out to one of our friends from IBM or one of our other friends from TechD, and we'll be sure to help you. And again, here's my information. So it's mmartina@tech-dynamics.com or generically info@tech-dynamics.com. Have a great day, everyone, and good luck with your big data.